The hum of the observatory dome was a low, constant thrum against the vast silence of the Antarctic night. Inside, Dr. Eris Thorne, his face illuminated by the pale blue glow of multiple monitors, tapped a nervous rhythm on his console. His colleague, Dr. Lena Petrova, a woman whose calm demeanor belied a mind sharper than any laser, leaned closer to her screen, a frown etched between her brows. The air was thick with the scent of ozone and stale coffee. "Still nothing, Eris?" Lena's voice was a soft murmur, barely disturbing the quiet. Eris sighed, running a hand through his already disheveled hair. "Nothing conclusive. The gravitational perturbations are still there, Lena, stronger than ever, in fact. But every direct imaging attempt, it's like staring into a void. Not even a whisper of infrared, no spectral signature, no thermal emission." They were hunting for something beyond the Kuiper belt, far past the icy realm of Pluto and its scattered kin. For months, their automated sky surveys had been picking up subtle, yet undeniable, gravitational anomalies affecting the orbits of extreme trans-Neptunian objects, ETNO. These objects, like Sedna and 2012 VP-113, exhibited clustered orbital paths and inclinations that defied the known gravitational influences of the 8 recognized planets. The leading hypothesis, Planet 9, suggested a super-Earth or mini-Neptune, perhaps 5 to 10 times Earth's mass, lurking in the deep cold, shaping these distant orbits. But Eris and Lena's data painted a far stranger picture. "It's not just the clustering anymore," Lena pointed out, pulling up a complex orbital plot. "Look at the precession rates of these 2 new objects, 2035 BH7 and 2036 ZK9. They're exhibiting an almost antigravitational effect in certain segments of their orbits. It's subtle, but it's there, like something is actively pushing them, not just pulling." Eris leaned in, his eyes widening. "Antigravitational? That's impossible. Unless we're talking about negative mass, and that's strictly theoretical, confined to speculative physics like wormholes or Alcubierre drives. Or," Lena mused, her gaze distant, "something entirely new. Something that interacts with gravity in a way we don't understand. A kind of exotic matter, perhaps, that cloaks itself from conventional detection methods." The idea was audacious, bordering on heresy in the astronomical community. Brown dwarfs, substellar objects more massive than gas giants, but too small to ignite hydrogen fusion, were difficult to detect due to their low luminosity, emitting mostly in the infrared. But even the coldest brown dwarfs, like WISE 855, had detectable thermal signatures. Whatever was out there, it was colder, darker, and far more elusive. Days bled into weeks. Team, a small but dedicated group of astrophysicists and data scientists, worked in shifts, fueled by caffeine and a growing sense of urgency. Dr. Kenji Tanaka, a brilliant young computational astrophysicist, was running complex N-body simulations, trying to model the gravitational influences required to explain all observed anomalies, including Lena's antigravitational hints. "The Planet 9 model fits the clustering of ETNOs, mostly," Kenji reported one morning, his voice hoarse from lack of sleep. "But when I try to incorporate the anomalous precession of BH7 and ZK9, the model breaks down. It requires a mass distribution that is not uniformly attractive. It's like a gravitational shadow, but with localized pockets of repulsion." Dr. Maylin, the team's resident expert in exotic matter and quantum astrophysics, had been quietly observing their struggles. She finally spoke, her voice calm but firm. "Kenji, can you model a scenario where a significant portion of the influencing mass is composed of a hypothetical exotic matter, one that interacts weakly with baryonic matter, but has an unusual gravitational signature?" Kenji blinked. "Exotic matter, like dark matter." "Dark matter is one form of exotic matter, yes," May explained patiently. "But dark matter is generally understood to be gravitationally attractive. What if we're dealing with something else? Something with a negative pressure component, or even a localized negative mass density, as theoretical physicists have toyed with for wormholes." The concept was mind-bending. Negative mass, if it existed, would accelerate in the opposite direction of an applied force. Such a phenomenon could, theoretically, create localized regions of gravitational repulsion. Kenji, though skeptical, was a scientist at heart. "I can try to code it, but the parameters would be purely speculative. Start with the simplest deviation," May instructed. "Core of standard matter, surrounded by a shell or halo of this hypothetical exotic component, one that generates a repulsive gravitational field under certain conditions, or perhaps even absorbs ambient thermal radiation, making it appear colder than the cosmic background." The simulations ran for days, chewing through petaflops of data. The initial results were chaotic, a mess of diverging orbits and computational errors. But Kenji, with May's guidance, refined the parameters, adjusting the density, distribution, and interaction cross-section of the exotic component. Then a breakthrough. "Look at this!" Kenji exclaimed, his voice cracking with excitement. A new orbital plot shimmered on the main screen. The clustered ETNOs were now perfectly aligned, and more importantly, the anomalous processions of BH7 and ZK9 were accurately reproduced. It's a binary system, May whispered, her eyes fixed on the screen. Not a single hidden planet, but two. One, a massive cold object likely a super-Earth or a small brown dwarf, perhaps 15 times Earth's mass. And orbiting it, or perhaps even embedded within its gravitational field, is something else. A companion object, far smaller, perhaps moon-sized, but composed almost entirely of this exotic matter. The simulation showed the exotic companion generating a localized, fluctuating